using the two methods. So, but did we do this one? Equation of a circle through 3 points.
Yes, madam.
No, madam.
No, madam.
I think you solved one example.
We did. I can remember we did. So I told you that when you have an equation of a circle through 3 points, you will be given the 3 points on the circle. Then you assume that the equation of the circle is x squared plus y squared plus 2gx plus 2fy plus c equal to 0. Then you substitute the values of the points P1, P2, P3 in tens. Then you're going to get 3 equations in 3 unknowns. So you use any simultaneously, so they are going to be, you can solve them simultaneously, or you can use any method that you know you can use to solve, maybe matrix approach or any approach. Okay, so you solve to get the values of x, g, f, and c. Okay, so and the next step is to you draw a line to meet the 3 points. So you have P1, P2, P3. Then you draw a perpendicular bisector for between, so for P2 and P3, the perpendicular bisector, and then P1 and P2, you find a perpendicular bisector. So you find the equation of the perpendicular bisectors, M and N of each called P1, P2, and P2, P3. Then the center of the circle is the intersection of the two bisectors. Okay, so you have the equation M and equation N. So you solve the two. When you solve, the intersection will be the center. Then after finding the center, you can find the radius. The radius is the distance from the center to any of the points, either P1, P2, or P3. Okay, so after finding the radius and then the center, you use the formula r squared is equal to s minus a all squared plus y minus b all squared. Okay, so if you don't remember, then we can look at this. It says that we have the points P1, P2, P1, P, Q, R on the circle S. We want to find the equation of S. We solved this. We solved this one part, I remember. So here we are given 3 points on the circumference of the circle. And we let the equation of the circle be s squared plus y squared plus 2gs plus 2fy plus c equal to 0. So we substitute the values, the coordinates of P. Okay, so P is -4, 2. So in place of X, I'll substitute -4. In place of Y, I substitute 2. So I have -4 squared plus 2 squared plus 2G, -4 plus 2F2 plus C equal to 0. You simplify, you're going to get 8G minus 4F minus C equal to 0. So that is for the first one. Then the second one, that is Q, we have -2 and then 6. Is there a hand up or somebody joined? Okay. So you substitute -2 for X and then 6 for Y. So you have -2 squared plus 6 squared plus 2G -2 plus 2F6 plus C equal to 0. Then when you simplify, you're going to get 4G minus 12 F minus C equal to 0. So that is the second equation. Then the third, we substitute 4 and 8. So we have a squared plus 4 squared plus a squared plus 2G 4 plus 2F 8 plus C equal to 0. So after getting the 3 equations, you simplify. The third one is like this. Then after getting the 3 equations, you know how to solve simultaneous equations. So this is 4. This is 8, this is minus. I think the last one too, we have -4, and then something like that. Okay. So you just play around it from how you know how to solve a simultaneous equation. So the first one, we are saying that we are dividing through by 4. So this one, we are dividing this through by 4. And we're going to get J plus 2F is equal to minus 8. So I think it was minus 4, not 4. We are dividing through by negative 4. So sorry. So that this will be positive. So J plus 2 is equal to minus 5. Okay. Then, as I said, we are playing around it. So we are subtracting equation 5 and then from 10. So, equation 9. So equation 9 is this. This is equation 9. And then equation 10 is the other. When we subtract, you can see that the C will go away. I think here you don't even have C. Okay. So you take your time to go through. You're going to get 12J minus 4F is equal to 40. Then you can divide through by 4, this one. Then you're going to get minus 3J minus F is equal to 10. Then we can make F the subject. When we make F the subject, we're going to get minus 10 minus 3J. Then in place of F in equation 11, this is equation 11. In place of F, I will substitute this. Then when I substitute, I have J plus 2 into brackets minus 3F minus 3J is equal to minus 5. Then you play around it. So when you simplify, you're going to get your J to be negative 3. So even with J equal to negative 3, I can substitute it here. So that my F will be minus 10 minus 3 times minus 3. So that will be positive 9. So I have F is equal to minus 10 plus 9, which is F is 1. So I'm going to get F to be minus 1. Then I can put J equal to minus 3 and then F equal to minus 1 into any of the equations, but this one we decided to put it in equation 11. So when you substitute it, where is equation 11? Okay, so this is equation 11. Equation 11, I think there's a problem with it because I cannot find C. I think there should be C somewhere. So please, you can take your time to solve. But when you substitute, you simplify, you're going to get your C to be negative 40. So we have J to be negative 3, F to be minus 1, and then C to be negative 40. So we know that the equation, we said that it is X squared plus Y squared. Please, this J should not be there. It's a typo error. So Y squared plus 2 into brackets minus 3 times X plus 2 into brackets minus 1, Y plus negative 40 equal to 0. You simplify, you're going to get X squared plus Y squared minus 6X minus 2Y minus 40 equals 0. So that's the equation of the circle using the first approach where you substitute the points into the equation in tens. Then the second method, said that we should find the equation of the perpendicular bisector of PQ and then the equation of the perpendicular bisector QR. Then the center is the midpoint of the intersection of the two. And then the radius is PC or QC or RC. Okay, so what we have to do to find the equation of the perpendicular bisector, I have to find the gradients. Then I will use any of the points to find the equation. So taking PQ, we know that anytime I want to find equation, I have to find gradient. So using PQ, my gradient will be 6 minus 2 divided by minus 2 plus 6. And this is giving me 2. Okay. That is the gradient of PQ, but it is the perpendicular bisector. Perpendicular bisector means that the gradient of that line will be the negative reciprocal of the gradient of PQ. Okay, so the gradient of this line, if I call it M, the gradient of M will be minus 1 over 2. Okay. Then the midpoint of PQ, we know the midpoint of PQ. we can find midpoint of PQ. So using the midpoint formula, the midpoint will be, we know the formula, so that would be minus 3 and 4. So that would be the point, midpoint somewhere here. So I have the slope for this line. I have a point on the line. I can find the equation of that line. So using y minus y1 is equal to m into s minus x1. I know my m is minus 1 on 2. Then when I find my xy, I have to write. Please, are you following?
Yes, please.
Hello? Are you following?
Yes, please.
Oh, I should.
Yes.
Okay. Okay. So my equation will be y minus 4 is equal to minus 1 on 2 s plus 3. Then you play around, it's going to get s plus 2 y is minus 5 equal to 0. That is for the perpendicular bisector for P and R. I have to find the perpendicular bisector for Q and then R. So I have to find the slope for PR. Please, can you find the slope for me? PR, the slope. So you can have 8 minus 6 divided by 4 minus 2. So what do I get for that? What will be the slope of QR?
Negative 1 on 3.
Negative 1 on 3.
Positive 1 over 3.
Positive 1 over 3. So which one should we take? Is it positive 1 on 3 or negative 1 on 3?
Positive 1 on 3.
Positive 1 on 3.
Positive 1 on 3. Okay. Please, let's find the midpoint for QR. Let's find the midpoint. So the midpoint will be 4 minus 2 over 2.
1 on 7.
1, 7.
1, 7. Okay. So we have the gradient to be 1 on 3, and then the midpoint to be 1, 7. So we can find the equation of that perpendicular bisector by y minus y1 is equal to m into s minus x1. Okay. So that will give me y minus 7 is equal to minus, okay, sorry. So the gradient for the QR is 1 on 3. By the gradient for the perpendicular bisector, I said it's perpendicular. So that would be the negative reciprocal of 1 over 3. So that is negative 3. So my equation would be y minus 7 is equal to minus 3 into x minus 1. Okay, so you simplify, you're going to get 3x plus y minus 1 equal to 0. Okay, so I have equation. Okay, so I have equation for this line and then equation for this line. To find the midpoint is the point of intersection. So I have to solve the two equations simultaneously. So I have 3 plus x plus 2y minus 5 equal to 0. 3x plus y minus 10 equal to 0. So I have, who is that? Okay, so when we solve the two simultaneously, I hope you can all do it, and I know you can even use the calculator. So when you solve, you're going to get your y to be 1 and then x to be 3, and that is the midpoints. So when you solve the 2 points, that is the center. Okay, very one. Now you have the center, so you can find the radius. The radius will be center to any point. Okay. So you have the center, This is the center. And then the radius, square root of, okay, so you know how to find the radius. Okay, square root of this, and this will give me root 50. So using the equation x minus a plus y minus b is equal to r squared, I'm going to get x minus 3 plus y minus 1 equal to square root of 50 squared. And you simplify, going to get x squared plus y squared minus x squared minus 2y equal to 40. And we can see that this is the same as when you use the first method. Okay, so the first method gave us this, and this one is also giving us this. So you can use any of the two to get the same solution. Any question before I continue? Please, can I continue?
Yes, please.
Yes, madam. Yes, you can continue.
Okay, thank you very much. So we want to continue equation of a tangent and normal to a curve, to a circle at a given point on the circumference of the circle. So we'll also learn how to find the equation of a circle given the center and the tangents at a point on the circle. So we want to look at tangents to circles. A tangent to a circle is a straight line which touches the circle at only one point. So when we say that something is tangent to a curve or a circle, it means that it touches the curve at only one point. And this point is called the point of tangency. And then the tangent to a circle is always perpendicular to the radius. Okay. So if it's a tangent, this line is a tangent to the curve, and it is perpendicular to the center. From the figure, PT is a tangent to the circle, and CP is the radius of the circle, which is also perpendicular to PT. If the gradient of PT is M1 and the gradient of CP is M2, then PT is perpendicular to CP. Then since PT is perpendicular to CP, then the gradient of CPM2 is equal to -1/m. So example, it says that find the equation of the tangent to the circle at this point. Okay. So now I want to find the equation of the tangent. So yeah, we are given, please excuse me, Martina. Please excuse me. Okay, sorry. Okay. So we want to find the equation of the tangent. We are given the point P, but we don't have the center. We are told that the point to the center, they are perpendicular. Okay. So even I can find the gradients and then also be able to find the equation. Okay. So first, let's find the center, and then with the center, we can find the gradient for CP. Then we know that the gradient for PT will be the negative reciprocal for the gradient for this. Then after that, we will use the point given to find the equation of the tangent. Okay. So let us compare the equation of the circle this to the general equation of a circle. Okay. We know the general equation is x squared plus y squared plus 2gx plus 2fy plus c equal to 0. So when we compare the two, we can see that our J is -1 and our f is +2. And we know that the center of the circle is -g minus f. So the center will be 1 minus 2. So I know the point P, and then I know the center. So I can find, yeah, Joseph.
Madam, please, can you take your time and then take us through the thing again, please? Because it seems you are moving too fast.
So we have the equation to be x squared plus y squared minus 2x plus 4y minus 15 equals to 0. And then we have a point P with coordinates 3, 2. Okay, so we know that we are finding the equation of the tangent. So I draw the circle, then I have a tangent, and then tangent has the point P. Now I have a center. The center is this. I want to find the equation of the tangent. Okay. Okay, but I was told that the gradient, if the gradient of m of this is m1, then the gradient of this is m2. I know that my m2 is equal to negative reciprocal of m1. Okay. Now to find the gradient, I know that I have to find the point P and then the point C to be able to find the gradient. I'm given the point P. I have to find the point C. Okay. So to find the point C, I'll compare this equation to the general equation of a circle, x squared plus y squared plus 2gs plus 2fy plus c equal to 0. So when I compare, I can see that I have 2gs is equal to minus 2x. So it means that my g is minus 1. And please excuse me. Martin, what to be? Yes, madam. Pacho, I'm coming. Hello. Sorry. So I have 2fy is equal to 4y. So y goes with this. Then I have y to be equal to 2. But the center of the circle is minus g minus f. So it means that my center will be 1 minus 2. So now I have the center to be 1 minus 2. I can find the gradient m1. So my m1 will be, I can have minus, so p is 3, 2. So I can have minus 2 over 1 minus 3. And what do I have? Please, what do I have? Minus 4 over minus 2.
Minus 4 over minus 2. What would be 2?
2.
This will give us 2.
So it means that my m2 will be, what is m2? My m1 is 2, so my m2 will be
Negative 1/2.
negative 1 over 2. Okay. So having this as the gradient for the tangents and having this point, I should be able to find the equation of the tangent. So the equation of the tangent will be y minus 2 is equal to minus half into x minus 3. So this is 2y minus 4 is equal to minus x plus 3. Pacho, you made that say. So 2y plus x, then this is minus 7 is equal to 0. That is the equation of the tangents that we are looking for. So I have x plus 2y minus 7 equal to 0. x plus 2y minus 7 equal to 0. So that's what we are looking for. Please, are you okay?
Madam.
Yeah.
Hello, madam.
Yes, please, I'm here.
Please, can you quote the formula for me for the calculating equation of tangent of a circle?
Hey, do you have the formula?
Come again, please.
We don't have a formula. You just have to find the gradient for the center to the point, and then you know that from center to the point, if the gradient is m1, then the gradient for the tangent line will be the negative reciprocal of that gradient. Then we know that for finding the equation of a line, when you have the gradient and you have a point, you know how to find the equation of the line, which is y minus y1 is equal to m into x minus x1. Are you okay?
Yes, please.
I know you are confused, but please take your time and read the notes. You just have to find the gradient for the CP. Then when you get the gradient for C and P, the gradient for P and T will be the negative reciprocal. So that's what we have. So if you get the gradient for PT, and then given any points, you use the equation for formula for finding equation of a line, which is y minus y1 is equal to m into brackets x minus x1, and that will give you the equation of the tangents. Okay, let's continue. So that's it. Another one, we want to find the equation of a circle with center 1, 2, and having the line this as a tangent. So here we are looking for the equation of the circle. We are given the line, the tangents. Okay, so let's this. So you have the equation this. Okay, then from the equation of the tangent, we obtain the equation of the tangent. So from here, you make y the subject, and you see that your y will be equal to -3 on 4 minus 10 on 4. So this thing here, when you take your time to write, it will be y is equal to -3 on 4 minus 4 on 3. And then we know that when I have y is equal to ms plus c, my gradient is the m. Okay, so I have, let me just write it so for everyone to see. Okay, so we have the equation to be 3x. So I have 3x plus 4y plus 10 equal to 0. So I can rewrite this as I want to make y the subject. So I have y is equal to -3 on 4 minus 10 on 4. When I make x, I have x here. Okay, and we know that comparing this with m is equal to ms plus c, where m is my gradient. So the gradient of the tangent line will be, so gradients. Actually, I'm going to change it. I don't know there's no, I shouldn't change it. So shut down when I. What's my change? You put it down. Please excuse me. Okay. So comparing this with this, my gradients will be, sorry, my gradients will be -3 on 4. Please, we are looking at this and this. Sorry, it should be a tangent. Please, you cannot touch it on. Okay. So a circle and a tangent is there, it's not touching. and a tangent. Okay. Okay, so this one has equation 3x plus 4y plus 10 equal to 0. And this has gradients. So the gradient is -3 on 4. We can find the gradient of this line. So the gradient of this line is the negative reciprocal. So the gradient will be 4 on 3. So that is it. So we are saying that it has the equation and the gradient 3 on 4. And then the gradient, this implies that the gradient of the radius, which is perpendicular to the tangent, is 4 on 3. So the equation of the tangent of the radius. So this one, we are given the radius, we are given the center. Okay. So we have the center, and now we have the gradient. So we should be able to find the equation of the tangent of the radius. So the equation will be y minus 3 is equal to 4 on 3 into x minus 1. Then when you solve, we are going to get 4x minus 3y plus 5 is equal to 0. Okay. Now we want to find the point of intersection. Okay. So we have this, we have the center, we have this equation, we have the equation for this. We want to find the point of intersection, this point. Okay. So to find the point of intersection, I have to solve the two equations simultaneously. So I'm solving the two equations simultaneously, this equation and this equation. So how to solve it? You can use a calculator. You can just try to solve. And when you solve, you are going to get your y to be -1 and your x to be -2. Is there a hand up? Okay, Joseph, your hand is up.
So, madam, in an examination, you can use calculator and then without showing working?
No. If it is written exams, then you have to show working. But if it's an objective, then you can just use your calculator.
Okay. So, madam, if
So
I
when
can, if I can make something, it means that the gradient of a tangent is the negative reciprocal of that gradient, right?
Yeah. One. The center. That is the center is 1, 3. So I have 1 and then 3. So having 1, 3, I can find the radius. Radius is the length. So using the formula, my radius will be square root of x minus x1 squared plus y minus 1, y minus y1 squared. So 1 plus 2 squared plus 3 plus 1. Then when you simplify, now I have the radius center of the circle. So I should be able to find it. Use the x minus equal to r squared. Okay. So I have 1 minus 5 squared. And we're going to get plus y minus 6y minus 15 equal to 0. And this is what I'm looking for. Any question before I move on to the
Hey, I can't see anything, or is it from my side?
Can I continue?
No, we can't see anything.
That the screen is not coming.
Please, can I continue?
Please, your screen. We can't see the
Am I
screen.
online?
Please. Madam, your screen is not showing.
Hello.
Madam, the screen is
Hello.
not coming. The screen.
Hello, madam.
Oh, hello.
Hi.
Hi.
Yes, madam.
Hello.
Hello, madam.
Yes, madam.
Yes.
Your screen is not coming.
Then we are saying that your screen is not showing.
Okay, I hear. Let me check. Hmm. Hello.
Hello, madam.
Hi.
Hello, madam.
Hi, madam.
Hi.
Yeah, please, can you see my screen now?
Yes, please.
Okay.
Yes, madam.
So, okay. So we've been able to find the equation of the circle given the center and then the equation of the tangents. Any question before we continue? Hello, any question?
Yes, please.
Can you hear me? Can I continue?
Yes,
Yes,
please.
madam. Yes, madam.
Okay. So now I want to look at normal to the curve, to the circle. As we saw earlier, a line that touches a circle is a tangent. Normal of a curve is the line perpendicular to the tangent. So a line which is perpendicular to the tangent is a normal to the curve at the contact point. In the case of circles, normals are radii, as radius is the normal to the tangent. So when we talk about normal to the circle, we are talking about the radius. If the gradient of the tangent is m, and the gradient of the normal is m2, so the gradient of the tangent is m1, the gradient of the normal is m2, then the gradient of the normal is equal to m2 is equal to negative reciprocal of m1. So example, want to find the equation of the normal to the circle x squared plus y squared minus 4x plus 6y minus 104 equal to 0 at the points negative 4 and 6. Okay. So we have a point on the circle as this. Then we have the equation of the circle. So we want to find the equation of the normal. Okay. Okay, so we have a circle. Then we have the center C, and then there's a point P here. And then we are told that the normal means the radius. You are looking at the radius. This is that tangent. This line is tangent, but the normal is this line. Okay. So here we are given the equation of the circle to be x squared plus y squared minus 4x plus 6y plus 104 is equal to 0. Is it plus or minus? Okay, plus minus 104. And then the point P is
Negative 46.
negative 46. So we want to find the equation of this radius. Okay. So first you have to compare this with the equation of a circle. Okay, the general equation.
Your network is breaking. We can't hear anything.
Can you?
Madam, please, we can't hear you.
We
Hello?
can't.
We can't see, we can't hear. Yeah, blow.
Charlie, seriously.
Insha? School. Too funny. This challenge. I'm going. Hurry up. Please, can you hear me now?
The only one or it's a general problem?
Sarah. Problem. You couldn't bring to. Hello.
Madam, please. Yeah, madam, we can hear you.
Hello. I know. Hello.
Hi, madam. We can hear you.
Mama make you feel better now. I am cautious. Let's continue. So what is my F and what is my G? Given the equation x squared plus y squared minus 4x plus 6y minus 104 equals to 0. What is G and what is F?
Negative 2, 3.
Hello? Negative
Jane
2
is -2
and
and
then
then
3.
3.
But the center is minus G. But the center is minus G minus F. So it means that my center is 2 minus 3.
2,
So I have the
3.
center here. Then I was given the. So let's find the gradient CP. So let's find the gradient. Gradient for CP. So what will be the gradient for CP? We have C to be 2 negative 3. 2 negative 3, and then we are given the point minus 4, 6. Let's find the gradient for CP. CP will be what?
Three on 2.
The gradient
Hello?
will be negative 3
Minus
on 2.
3 on 2.
Negative 3 on 2. So that is
On
the
2.
gradient for this. Then let's find the equation of the normal. So I have so find the equation of the normal to me. For me, you have the gradient negative 3 on 2. You have the center and another point. So find the gradient for me. The equation, sorry, the equation of the normal.
2y plus 3x is equal to 0.
2y plus 3x is equal to 0.
Equal to 0.
Did you all get this? 2y plus 3x equal to 0. Did you all get that? So what point did you use? Which of the points did you use? The center or the point given?
The point, negative 4 and 6 and the gradient.
Okay, so when you take the time and then solve, you're going to get 2y plus 3x equals to 0. That is the equation of the tangents. The other one, want to find the equation. Okay, sorry, not the tangent, it's the equation of the normal. So another one, want to find the equation of the normal to the circle with center. This at the point 0, 0. Okay, so this one, this is the point, this is the center, and then we have the point 0, 0. So what we have to find is just the gradients. So the gradients will be, it says that the gradients, okay, so the gradients will be minus 2 over 4, minus 0, and then 4 minus 0, which is minus 2 over 4, which is negative half. Okay, there's a hand up. Foster, your hand is up.
Yes, please, madam. Please, I want a clarification here.
Hello, Foster.
After getting the gradient, hello, madam. I'm not
Okay.
speaking. Hello, madam.
Yeah, I'm listening.
Please, I
I'm
am
listening.
seeking for a clarification. Yes, please. I'm seeking for a clarification on the question we just solved at the other side of the board, pertaining to finding the gradient of the
Okay.
CP, and you got, sorry, and we got -3 on 2. Finding the equation
Okay.
of the normal. I think you said we have to use the point P, which is tangent to the circle. I want clarification.
It's not tangent, so it's just a point. It's just a point on the
A
circle.
point.
So that's when we don't.
Okay. Okay.
So
So it's just a point. Thank
that
you.
when we have that, we circle points, you can have radius. So here we have this center here, and then a point here. If the point is here, it will still be the point to the center will still be the radius. So we just saw that the normal is the same as the equation of the radius.
Okay.
Okay, thank you. So the next one, I want to find the equation of the normal to the circle with center, this, and at a point 0, 0. So at a point 0, 0, we know we have to find the gradient. So the gradient will be -2 minus 0 over 4 minus 0, which is -102. Then we can use this point, 0, 0, half y minus 0 equal to -102 into x minus 0. And when you solve, the equation will be x plus 2y equal to 0. I'm continuing. Can I continue?
Yes, please.
Yes.
Yes, please.
Okay, so then the next, I want to look at intersection of a line and a circle. To find the points where a line and a circle meet, the method of substitution between their equation is used. If there is only one point of intersection between a line and a circle, then the line is a tangent to the curve, to the circle, as we learned in the previous section. So we'll look at 3 cases. We'll look at so 3 cases under the intersection of a line y is equal to ms plus c1, and the circle s squared plus y squared plus 2gs plus 2fy plus c equal to 0. So if r is the radius of the circle and d is the distance from the center to the straight line, and c is the center of the circle, we are going to get 3 cases where there are 2 distinct points of intersection. So I'm looking at a line and then a circle. So the circle, the line can be a chord to the circle like this. So I have the circle and then the line being a chord. So it will cut the line at 2 points. And when we compare the distance, we can see that the distance from C to D will be less than the radius, because the radius will be from the center to the other point. So we are saying that when the line is a chord, it touches the circle at 2 points, then the length CD will be less than our radius. In case is when it's a tangent. When the line is a tangent to the curve, then the distance from CD will be the same as my radius. So D will be equal to R. And the third case is where there is no intersection. Okay, so where there is no intersection, then the distance from C to D will be greater than my radius. Okay, so we want to look at steps for finding the point of intersection of a line and a circle. So what you have to do is first, you make x or y the subject from the equation of the line given. So you know that the equation of the line is y is equal to ms plus c. So you'll give the equation of the line, then make whichever one simple or use. So either you get as a subject or y subject its own. So you get x or y on its own from the equation of line. It says that look carefully and select the variable which will make the work easier. Then you substitute for same value into the equation of the circle. So when we make either x or y the subject, you substitute what you have found. If it is y equal to something, you go to the equation of the circle. Wherever you see x, so wherever you see y in the circle, substitute that value there. After that, you solve whatever you. So you see that if you make y the subject and you substitute it into the equation, then the equation will be in terms of x. So you solve for x. You get two values for x because it is x squared. Then the two values that you get, you substitute them into, so it says that substitute separately the value obtained in step 3 into the linear equation. So the two equations for x, the two values for x that you get, you substitute them into the equation of the equation of the line to find the corresponding value of the other variable. I mean the y, the x or the y. So example, find the point of intersection of the line x minus 2y minus 1 equal to 0 and the circle x squared plus y squared plus 4x minus 2y minus 5 equal to 0. Please excuse me.
Awesome.
Okay, sorry. Then I ask some. Then I ask some. Now the trainer and I say me break here na ne wa hin na ya some. Na nanti asene number.
Madam asa no network no danye.
Oh, ngono so.
Ana asa usa kontem kakra nti.
I say he just going through with us mathematics. Yes, yeah.
Hey, do I teach this? Then even after I'm sitting under some 3B, I'm trying to solve network.
Madam, actually, today your network is not helping you. That's the issue. Today your network is not helping you.
Hello, Abubakar.
Hello.
Yes,
Hi,
madam.
madam.
Yes, madam.
Madam, you are clear.
Yes, madam.
It's noisy with the network there.
Oh, yeah, yeah, yeah. We understand, madam. Today is 31st. That one too is a contributing factor.
Okay, thank you. So we want to find the points of intersection of the line x square x minus 2y minus 1 equal to 0 and the circle x squared plus y squared plus 4x minus 2y minus 5 equal to 0. And we know that to consider a point of intersection, we have three cases. Either the line will be at a chord, a tangent, or there will be no point of intersection. Okay. Then these are the steps. It says that given the equation of the circle, I have to try to express one in terms of the other. Okay. So looking at this, I can see that I can express the whole function, the x in terms of the other. So I'll make x the subject. So when I make x the subject, I'm going to get x to be equal to 2y plus 1. Then I have the equation of a circle. So the second point says that in place of x in the equation of the circle, I'll substitute 2y plus 1. So here will be 2y plus 1 squared plus y squared plus 4 into brackets 2y plus 1 minus 2y minus 5 equal to 0. So that is what I have here. So I continue to simplify. I expand. Then when I simplify, I'm going to get 5y squared plus 10 equal to 0. I divide through by 5, and I'm going to get y squared plus 2y equal to 0. So I solve this. This is a quadratic. I solve. I'm going to get my y to be 0 or y to be negative 2. So the next step after getting this, I have to substitute the y values into the equation x. So when y equal to 0, my x will be 1. So that point will be 1, 0. And then the next one is s equal to y equal to -2. So when I substitute y equal to -2, I have s equal to 2 times -2 plus 1, which is -4 plus 1, which is 3. So I have 3, -3, and then -2. So the points are 1, 0, and then -3, -2. So this means that we have 2 points of intersections. So it's a chord. So it is this point. Please excuse me. Okay. So from what we saw, you've seen that we have 2 points of intersections. So it's the first one. Okay, so the coordinates of the points of intersection are 1, 0, and -3, -2. Then there's another one. We want to find the point of intersection of the line 3x minus y plus a is equal to 0 and x squared plus y squared minus 4x minus 8y plus 10 equal to 0. Please, am I online?
Yes,
Yes,
madam.
madam.
Okay. So here we have to make y the subject, because making y the subject will be easier. Okay. So making y the subject, we're going to get our y to be 3x plus 8. Then in place of y, I'll substitute 3x plus 8 in the equation of the circle. So I'm going to get x squared plus 3x plus 8 squared minus 4x minus 8 into bracket 3x plus 8 plus 10 equal to 0. Then I try to simplify. So when I simplify, I'm going to get 10x plus 20x plus 10 equal to 0. I divide through by 10, I'm going to get x squared plus 2x plus 1 equal to 0. Then I have to solve for x. This is a quadratic equation. So you solve the quadratic equation. So when you solve the quadratic equation, you are going to get your x to be -1 and a -1. So it's a repeated root. So it's a repeated root, and we have to find our y. Our y is 3x plus 8. So x is -1. So I have 3 times -1 plus 5 plus 8. So my y will be 5. So y will be 5. It's a repeated root, so it means that it's going to be a tangent. So it's going to be a tangent because it is the x values are repeated. It's the same thing. If you get 2 values, then it means that it's going to be a chord. But if it's repeated, then it means that it's a tangent. And the last one, I don't think I have a example on that. But the last one is going to be, when you solve, you're going to get an imaginary point. When you get an imaginary point, then it means that it is the third case. It is the third case. So they have the third case when we have imaginary points. So that is, since you're going to get a quadratic equation, you can use the discriminant b squared minus 4ac. to find out if you're going to get repeated roots. So b squared minus 4ac equal to 0 means that we're going to get repeated roots. We have greater than 0 means that we're going to get distinct roots, and then less than 0 means that we're going to get imaginary roots. So when you have imaginary roots, then it means that it is the third case. Okay. So now you know how to find the center and the radius of a given circle, equation of a circle. You know how to find the equation of a circle given the coordinates of the endpoint of the diameter of the circle. Then passing through 3 points, find the equation of the tangent and normal at a given point on a circle. How to find the coordinates of the point of intersection of a straight line and a circle. We have some questions here. You can try your hands on. So please, these are questions. Try them, please. Try them. Try them, oh. Try them. You see, questions, so try them. Because I may not be able to get another questions for you. But try these questions, please. Thank you.
Yes, ma'am.
Thank you. Any question for me before we move on to the next slides? Any question?
Madam,
You have a question? Okay. Foster, please talk. Yeah, wait, we are listening.
Madam, please, with regards to the last one, after maybe finding the values, are we to state whether it is a chord or it is a tangent or otherwise?
Yeah, please state.
Okay, thank you.
Please state. Okay, you're welcome. Let me see. So this is week. Let me see. This is week 3. This one.
hello, madam.
Yes, dear.
Please, you do have the slide, so after you do a share for us.
Now here, I'll share it with you.
Please.
Madam, I have a question, but it's not on what we just learned. It's about the question we said we should try our hands on.
Okay.
I wanted to ask, like the end of SEM exams, will you be getting a different question from these 5 questions, or you pick them from them?
Oh, that one, I'm yet to think about it, but mathematics, there. Mathematics, if you get the concepts right, then you should be.
Understanding matters, not the question.
Yeah. So when you understand it, the question there, it's
application you apply.
So whether I'm going to pick it from picking there, I don't think so, but I don't know what will happen. I'm yet to set my questions.
I think so. It's New Year. Thank you.
Yes, dear.
Madam, please, which unit did we just finish?
Unit 2.
Unit 2.
Yes, please.
Thank you.
You're welcome. So we are moving on to unit 3, which is the limits of a function. So we are done with the first part, the analytic geometry parts. We want to start with the calculus parts. So we are unit 3, it's on calculus.
The calculus. People are going to die for you.
You will not die, please.
Calculus again. Calculus
so at the end of the course, the student should be able to demonstrate knowledge in limits of a function, continuous function, differentiation of functions using the first principle. So this is the only thing we're going to do here. How to find the limits of a function, how to determine if a function is continuous, and then also how to differentiate a function using the first principle. And I know that those who did elective maths, they know all these things. how to find the limits, how to find the differentiation using first principle. So outline, we'll look at limits of a function, evaluating limits, one-sided limits, relationship between one-sided limits and two-sided limits. We'll look at discrete theory. We'll look at continuity and then derivative of a function. So let's look at the limits. The limit of a function. Limits. I've reached my limit. She has reached her limit. It's a everyday English that we use. So the limit describes what happens to the value of the value f of x of a function as s approaches a number a, as opposed to f of a, which gives the value of the function when s is equal to a. We say f of s has the limit L as s approaches the number a, provided that f of s becomes and remains closed to L as s becomes closed but not equal to a. This is expressed by writing lim s approaches a of f of s equal to L. Okay. When such a number L exists, we say that L is the limit of f of s as s approaches a, or simply L is the limit of f at a. Okay. So let's look at how to evaluate limits. Now we have to evaluate the limit. You have to look at the type of a function that you are looking at. So the first one, we want to look at how to evaluate polynomial functions. And I hope you know the polynomial functions. When we talk about polynomial functions, we are talking, do you know polynomial functions?
Yes, please.
So give me an example of a polynomial function.
F of x equals x cubed plus 2x squared plus x minus 1.
What kind of a polynomial function is that? What name do we give to the polynomial function you just mentioned?
Cubic.
Okay, so cubic function. So cubic function is a polynomial function. Can someone give me another example of a polynomial function?
3x plus 2.
3x plus 2. What name do we give to 3x plus 2?
That's a linear function.
Linear.
Okay, any other polynomial function?
2x plus 1. 2x squared plus 1. X.
2x squared plus 1. Okay, so what kind of a linear polynomial function is that?
Quadratic.
Madam, that's a quadratic. It's not
okay, so these are quadratic function, linear functions, cubic function, and others. They are all polynomial functions. So any function that can be written as a times s to the power n. So any function that can be written as this: ax to the power n plus an minus 1 s to the power n minus 1, going up to 0. These are called polynomial functions. Okay. So we want to look at how to evaluate the limit of polynomial functions. It says that if f is a polynomial function and a is a real number, then to evaluate the polynomial function at a, we write it as lim s approaches a of f of s equal to f of a. So if the function given is a polynomial function, what you have to do is you just substitute the value of your a given. So when the function given is a polynomial function, you substitute the value of your a given. So example, want to evaluate this. Lim as s approaches 1 of 2x plus 1. So since this is a polynomial function, wherever I see x, I will just substitute 1. So this one will give me 2 times 1 plus 1, which is 2 plus 1, which is 3. So if it's a polynomial function, this is how we solve it. Okay, for example, if I have so I want to find the limit as s approaches 0 of x5 plus 2x3 plus 2x plus 1. What will I get for this?
1.
Okay, so I will substitute 0, 0, 0. So this one will give me 1. So this is a polynomial function. So I want to find the limit.
Where from the one? Where from the one, please?
You are substituting
You
you are substituting s equal to 0. So 0, 0, 0, 0 plus 1 will give me 1.
Okay. Thank you, madam.
Okay, welcome. So you know how to find the limit of a polynomial function. Then the next one, I want to look at how to find limits of rational functions. So rational functions, when we talk about rational functions, we are talking about functions that can be written as f of s over g of s, or maybe q of s. So I have f of s is equal to g of s over q of s, where g of s is not equal to 0. Okay, so we want to look at how to find the limits of functions like this. Now, to find the limit of a rational function, first, what you have to do is you have to find the domain of the function. So if Q is a rational function and A is in the domain, so you find the domain, and if your A given is in the domain, you just substitute your A into the function. So example, want to evaluate the limit as s approaches 3 of s squared minus 2s plus 1 over 3x minus 3. Please, what is the domain of this function?
Madam, it's 3x minus 2.
The domain.
2 over 3.
Madam, it is x such that x belongs to a set of real numbers. X is not equal to 2 over 3.
Please come again.
The domain will be x such that x belongs to a set of real numbers. It is
okay.
X such that
Enough. Okay.
Yes, please. X such that x
Yeah,
belongs
please,
to the set of
let me write. Let me write. So the function is want to find the limit as s approaches 3 of s squared
minus 2x plus 1
minus 2s plus 1 over 3x minus 2. Is it 3x minus?
Yes, please, madam.
So want to find the domain, and you said the domain is x such that x belongs to the real numbers, but x is not equal to
2 over 3.
2 on 3. Please, how did you get this?
So for the function to not be defined, then 3x minus 2 will be 0. That means we are not supposed to get the denominator to be 0, but at the top any value
so
of x
for a function to be defined, the denominator should not be equal to 0.
Yes, please.
So you have to solve for the value of x that will make s the denominator to go to 0. Okay, so that would be 3x minus 2 equal to 0, and this will be s equal to 2 on 3. Okay, so what does that mean? It means that 3 on 2 this function undefined.
Yes, please.
So it means that 2 on 3 is not in the domain. When you talk about the domain, we are talking about the values of s that will make this function defined. So any value that will make this function undefined is not in the domain. Is that not it?
Yes, please.
So it means that 3 on 2 is not in the domain. Okay. So our domain is x such that x belongs to all real numbers from negative infinity to positive infinity, except 2 on 3. Okay. Is 3 in the domain? We have x approaches 3. Is 3 in the domain?
Yes, please.
Do you all agree that 3 is in the domain?
Yes, please.
Yes, yes.
Yes.
Chris.
Okay, so 3 is in the domain. So what value of x is not in the domain?
2/3.
2 over.
2/3.
So it is only 2 over 3 which is not in the domain, but 3 is in the domain. So the theory says that if the a given is in the domain, you just substitute that s value into the function. So he says that since 3 is in the domain of the rational function, we have, so I will substitute 3. So I have 3 squared minus 2 times 3 plus 1 over 3 times 3 minus 2. And when I simplify, I'm going to get 4 on 7. So that's how to evaluate rational function. You look for the domain, then if the value given, the a value given is in the domain, you just substitute it. The next one is saying that if q is a rational function and a is not in the domain of q, then simplify the rational function before evaluating. So we have an example. We want to evaluate the function. So this is limit as s approaches 4. Please, this is a mistake. It's not approaching 2, it is approaching 4. As s squared of s squared minus 6 over x minus 4. What is the domain of this function?
Four.
Somebody spoke. Who answered?
Adam.
Who is that?
Yes, sir.
Oh, is it Opoku? Please, what's the domain of the function of this function?
X will say
Yes.
that
X
X belongs
will
to
say
all
that
real numbers.
X belonging.
Oh,
Okay,
please let one person talk. So justice. What's the
okay.
domain?
X is said that X belonging to real numbers. X is not equal to positive 4.
Okay. So S is such that X belongs to all real numbers except positive 4.
Yes,
But here,
please.
as I said, we want to find the limit as S approaches 4. So please, it is not 2, it is 4. Okay.
Okay.
So this means that the A value is not in the domain because you are told that X is equal to 4 is not part of the domain. So our A value is not in the domain. So the B says that if Q is a rational function and A is not in the domain of Q, then simplify the rational function before evaluating. So let's simplify this function. Can you simplify this for me? X squared minus 16 over x minus 4. Can you simplify
Yes, madam.
it? Okay, so
I will
simplify.
get
X
plus
plus
4.
4 in one bracket, x minus 4 in another bracket.
Okay, so you have x plus 4, x minus 4 divided by x minus 4. So when you simplify, what do you get?
X plus 4.
X plus 4.
Plus
Okay.
4.
Okay, so you are saying that since 4 is not in the domain of the rational function, we will simplify the rational function. So you have limit as s approaches 4 of x squared minus 16 over x minus 4. And as you said, it is x minus 4, x plus 4 over x minus 4. So x minus 4 will cancel x minus 4. Then I'll be left with the limit as s approaches 4 of x plus 4. And now I have a linear function polynomial function. So I'll substitute the 4, and this will give me 8. Are you okay?
Yes, please.
Okay, so we have
Madam, go over it again, please.
So we just saw that 4 is not in the domain. So B tells us that if the A value is not in the domain, you have to simplify. So we are simplifying x squared minus 16 over x minus 4. When we simplify this, x minus 16, you can use difference of 2 squares. So this is x minus 4, x plus 4, all divided by x minus 4. So x minus 4 will cancel x minus 4. I'll be left with x plus 4. And you can see that x plus 4 is a linear function, which is a polynomial function. So to find the limit, I will just substitute the 4. So I have 4 plus 4, which is 8. So that's it. You're welcome. So now we want to look at laws of limits. Laws of limits. Okay. So if f and g are functions such that the limit as s approaches a of f of s and the limit as s approaches a of g of s exists, then we have the following laws. First, we want to look at sum or difference of two functions. So the limits, okay, so limits of the sum or difference. So limits as s approaches a of f of s plus g of s, or f of s minus g of s, is the same as find the limits as s approaches a of f of s. If it is sum, then plus the limit as s approaches a of g of x. So you can find them separately. You can find the limit for f of s and then the limits for g of s, and it will be the same as find the limits for both of them. And then the second one, the limit of a product of two functions. So the limit as s approaches a of g of x and then f of x. You can find the limit for g of x and then you multiply it by the limit of f of x. And then if it's a quotient, the limit of the quotient of the two is the same as find the limit of f of x, then dividing it by the limit of g of x. And then the next one, if I have a constant multiplying the function, then I want to find the limit of the product. It's the same as bringing the constant out and then find the limit of the function. And the last one, the limit as s approaches a of a function, the nth root of a function, is the same as finding the limit of the function and then finding the nth roots. So please keep these rules. We'll be using them, these laws. Okay. The next thing, I want to look at limits of trig functions. So we'll start with the basic trig limits. The basic trig limit is given by the following theory. Let x be an angle measured in radians. Then, so we have an angle. Then first one, the first rule says that the limit as s approaches 0, please, the limit as s approaches 0 of sine x over x is equal to 1. So this is the theory. So given this theory, we want to find the limit as s approaches 0 of tan x over x. So we have this theory for the trig. We are using this theory. So the theory says that the limits as s approaches 0 of sine x over x is equal to 1. So having this in mind, we want to evaluate the limits as s approaches 0 of tan x over x. We want to evaluate the limit as s approaches 0 of tan x over x. So my solution, I can write this as the limit. Why then? Please missing the money. So I can write tan, I know tan x is sine x over cos x. Do you remember? Please, you remember?
Yes, madam.
So tan x is, okay, so let me write it as it is. So it's a sin x over cos x all divided by x. And this is the same as the limit as x approaches 0 of sin x over cos x times 1 over x. But I have this theory in mind. So I have to play around it to get that theory. So this is the same as the limits as s approaches 0 of sin x over x times 1 over cos s. Is it correct? That this can be written as this. Limit as s approaches 0 of sin x over x times 1 over cos s.
Yes, please.
Please, you agree? Okay.
Yes, please.
Yes, please.
And then using one of the rules, it says that product of two functions, I can have it as limit as s approaches a of f of s times the limit as s approaches a of g of x. So I can write it like this. So this will be equal to the limit as s approaches 0 of sin x over x times the limit as s approaches 0 of cos s. 1 over cos s. 1 over cos s. When you just, from the theory, we know that the limit as s approaches 0 of sin x over x is what?
1.
1. Okay. So I can have it as, so the limit as s approaches 0 of tan x over x is equal to 1 times the limit as s approaches 0 over 1 over cos s. Okay. So the limit as s approaches 0 of 1 over cos s, so I will substitute 0 in place of x here. What is cos 0?
1.
Cos 0 is 1. So I have 1 over 1, which is 1. So this is giving me 1. So the limit as s approaches 0 of tan x over s is equal to 1. Are you okay?
Yes, please.
Okay. So that is it. So we have that to be 1. Then another example, we want to evaluate the limit as s approaches 0 of 4x over x. Remember that for this theory to work, the angle here should be the same as the angle here. So in the example given, we have the limit as s approaches 0 of sine 4x over x. The angle here is 4x, angle here is 4. Okay. So we have to play around this so that the denominator too becomes 4. I know that any function times 1 is the function itself. So what I will do is I'll multiply this function by 4 and then I'll divide by 4. So I can write the limit as s approaches 4 over 4 as the limit as s approaches 0 of 4 sine 4x divided by 4x. So I'm multiplying through by 1, which is 4 over 4. And then one of the rules says that if I have a constant, the fourth one, I have a constant times a function, I can bring the constant out. Then I find the limits of the function. So I have 4 here, I'm bringing the 4 out. Then I have the limit as s approaches 0 of 4x over 4x. Then the theory says that the limits of sine of an angle divided by the same angle will give me 1. So the limit as s approaches 0 of 4x over 4x will give me 1. So this will give me 4 times 1, which is 1. You have another one here.
Yeah,
We have
come
the
on.
limit. The limit as s approaches 0 of cos 3s minus cos s over 3. Here we have to use some angles. So please, you can take your time to look at this one. This we have triple angle and others. So I'm giving this one to you as an assignment. The solution is here, but I want you to go and revise your compound angles, triple angles, and then half angle. Then you apply them here. So the next thing, I want to look at one-sided limits. One-sided limits. So if the limit as s approaches a from the positive, Abasawa, please. So the limit as s approaches a from the positive of f of s is equal to L. We say that the limit of f of s as s approaches a from the right is L. So here the focus is on this, a positive. The positive means that we are coming, so we are looking at the SY plane. So if I say look at the SY plane, I know it is like that. So when it is a positive, it means that I'm coming from this side. When it is a negative, then it means that I'm coming from the left. Okay. So we are looking at the right side limits of the function. Okay. So we will also refer to L as the right-hand limit of f of s as s approaches a. The symbol s approaches a positive is used to indicate that s is restricted to values greater than a. So it means that we are looking at values greater than a. Also, if we have the limit as s approaches a from the negative of f of s equal to L. See, I have to mute someone. Who is that? Okay, so the negative one means that we want to find the limit of f of s as s approaches a from the left. And this means that we want to look at the left side limit of f of s as s approaches a. And the symbol s approaches a negative is also used to indicate that x is restricted to values less than a. So example, we want to find the right, we are given the function f of s is equal to absolute of a. We want to find the right hand limit of f of x and then the left hand limit of f of x. So this is an absolute function, and the definition for absolute function is, so this absolute function, we can have two function. We can have the right hand and then the left hand. The right hand is x if x is greater or equal to 0. And the left hand we have negative x if x is less than 0. So the absolute function so when I sketch the absolute function, so absolute of positive numbers is positive, absolute of negative numbers is also positive. So I have this, I have this. When I take absolute of positive numbers, I'm going to get positive y values. So absolute of x, whether positive or negative, will give me positive x value, y value. So this has definition x for x greater than or equal to 0. Then I have negative s for s less than 0. So less than 0 is this part. Supposed to be a straight line like this. So anytime you have an absolute function, you have x greater than 0, greater or equal to 0. Then you have negative s greater than s less than 0. So for x greater than 0, it means that we are looking at the right hand limit. So the limit as s approaches 0 is this 0 of the absolute of x. This is, I want to look at x. So this is the limit as s approaches 0 of x. I don't know if it's approaching 0. Let me check. Are we approaching 0? Okay, so we are approaching 0 from the right. Okay, so approaching 0 from the right, this is positive. So 0 from the right means that I'm looking at x, and this will give me 0. Then I have the limit as s approaches 0 from the left of this function. This is the same as the limit as x approaches 0 from the left of that one. We saw that if it's from the left, I'm going to get negative x. So this is negative x, and this will also give me 0. Okay, so the limit as s approaches 0 from the right of the function, that is absolute x, that will give me positive x, and that is 0. And then approaching it from the left will give me negative x, and this is equal to 0. Now I want to look at the relationship between one-sided limits and two-sided limits. Now the limit of a function, that is the limit of the function at a, is equal to L. If and only if the left-hand side limit is 0, is 1, is L, and the right side limit is also L. So for this given example, if I'm to find the limits, so for this example, if I'm to find the limits as s approaches 0 of my function absolute of L, I have to find the left-hand limit. So this one, we have found the left-hand limit. We have gotten 0. We have also found the right-hand limit, and this is also 0. Now, if the right-hand limit is 0 and the left-hand, if the left-hand limit is 0 and the right-hand limit is 0, then I can conclude that the limit at 0 will also be 0. That is the relationship between the right-hand limit and the left-hand limit. Okay. So if the left-hand limit is L and the right-hand limit is L, then the limit at A will be L. I can see a hand up. Okay, Daniel.
Please, madam, if they are all equal to 0, what does that imply? And if they are not equals to, like one is equal to 0 and the other is not equal to 0, what does that also imply?
So if, and when I meet you, if both are 0, if from the right is 0 and then from the left is 0, then it means that the limit at the point itself. So example, if the limit at negative A is L, and then the limit as we approach A from the positive is also L, then it means that the limit at A will be L. If the limit at as s approaches A from the negative is maybe M, and the limit as s approaches A from the positive is K, then I can say that the limit does not exist. Because for the limit to exist, both the right hand and the left hand should give me the same. Then I can say that it exists, it is the same at the given point. Okay. So that is it. So we have an example here. Are you okay, Daniel?
Yes, please.
Okay. So example, we want to evaluate the limit as s approaches a of absolute of x minus 8 divided by x minus 8. Okay, so as I said, the absolute, I can rewrite this as x minus 8 over x minus, so this is the positive portion. So x minus 8 positive divided by x minus 8. And this one, we are looking at where x minus 8 is greater than 0. And then the other one, I have the negative portion, which is negative into brackets x minus 8. So I have negative into brackets x minus 8 over x minus 8. This I want to look at where this, the numerator is greater than 0, or s, the numerator is less than 0, or x is less than 0. Now x minus 8 over x minus 8 will cancel. I have 1. Then minus x minus into brackets x minus 8 over x minus 8. This will give me minus 1. So over here we can see that the approaching it from the right is 1, approaching it from the left is negative 1. So that's what I have. Approaching it from the right is 1, and then approaching it from the left is minus 1. So since the left and the right are not the same, then I can say that the limit at 8, the point 8, does not exist. So since the right and the left are not the same, we conclude that the limit for the function does not exist. Please, are you okay?
Madam, please, we need a bit clarification.
So let me use my example, the 0 example. So I want to find the limits as s approaches 0 of this absolute function. Okay. So the relationship between the one-sided limit and the left-hand, the two-sided limit is that to find the limit as s approaches 0, I have to find the limit as s approaches 0 from the left of this function. Then I find the limits as s approaches 0 from the right of the same function. Then I just told you that the definition for this function is I have x if x is greater than or equal to 0. Then I have negative x if x is less than 0. So let me take, I'm looking at one-sided. So let me just look at greater than and then less than. Now for the approaching it from the negative, it means I want to look at s less than 0. So thus I want to find the limit as s approaches 0 from the right of negative x. Negative x, when I substitute 0, this will give me 0. And then from the positive, I want to look at values greater than 0. So this one is the limit as s approaches 0 from the positive. And this one, the definition gives me x. When I substitute 0, this one is also giving me 0. The main question is to find the limit as s approaches 0 of the absolute. Now I've been able to find the limits as I approach it from the left. I get 0. Then I've found the limit as s approaches 0 from the right. This is also 0. So since the limit as x approaches 0 from the left is equal to 0, and the limit as s approaches 0 from the right is also equal to 0, then I can conclude that the limit as s approaches 0 of the function is equal to 0. it exists and it is equal to 0. So if the left hand side gives me the same value as the right hand side, then I can conclude that the limit for the function is the value that I got. Yeah, Justice.
Madam, please, I'm getting a little bit confused. I want to know if the limit at the left hand side is the negative one, then the one at the right hand side is the positive one.
The right hand side is the positive one, and the left hand
Okay.
side is the negative one.
Oh, okay. Because per the narration you were giving, I thought you confused me with the left and the right hand side, because when you were solving the negative one, you said you have been able to solve the right hand side, and so I was a little bit confused.
Okay, then I'm
Thank
sorry.
you.
It was a slip of.
Okay.
So this is right.
Thanks.
This is left.
Okay. Thank you, madam.
So, you're welcome. So if the left and the right are not the same, then it means that the limit does not exist. So the next thing we want to look at, we call it the squeeze theory. Squeeze or sandwich. Sandwich. So you know sandwich. When you go to KFC, you see some sandwich over there. You have the bread, they cut it into two, then they put something inside. They sandwich it. And then when you come to the university, we have what we call sandwich program. So we'll have the first semester and then the second semester. Then in between the two semesters, we have another program. Then we call it the sandwich. It is in between the first and second semester. Or squeeze. So you want to squeeze your orange. You have something up, down, then you put the orange inside, then you squeeze it. Squeeze. So it's the same as squeeze or sandwich. Okay, so suppose I have three functions, f, g, and h. So I have g, the function g, the function f greater or equal to, so the function f less or equal to g, and then g is also less or equal to h. So you can see that g is sandwiched between f and h. So the sandwich. So my g is between f and g. H. My g is greater than f, greater or equal to f, but less or equal to h. Now for each x not equal to a in an open interval containing a, if the limit as s approaches a of f of s is L, and the limit as s approaches a of h of s is also L. So the limit for f is L, the limit for h is L. Then it means that the limit for my g will also be L. So if the limit for f is L and the limit for h is also L, f is L, h is L, then the limit for g is L. So that is the sandwich. So example, we want to use the sandwich theory to evaluate this. Okay. So now I'm given my g of x. I have to find my f of x and then my h of x. So this is what I do. This is a trig function. I have a trig function here. And then when you look at the graph of the cost function, what is the maximum value the cost function can attain? I'm talking to you. Looking at the graph of, or looking at the cost function, what is the maximum?
Positive and negative one on the y-axis.
Okay, so the maximum value it can attain on the y-axis. So you can look at cos 90, cos 180, cos 260, 360, cos 720, cos the negative values. You can see that the maximum value that this cos function can take is assume is 1, and the minimum value is -1. So to get my g of x, to get my f of x, and then my h of x, this is what I will do. So I'm giving my g of x. I have to find my f of x and then my h of x. So I have cos, I have cos s, and you just told me that the minimum value is, it is maximum. Minimum is here. The maximum is here. Okay, so you just told me that the cos function, the maximum is 1, and then the minimum is -1. I look at my function. Where is my cursor? So let me multiply through by s squared. When I multiply through by s squared, I'm going to get -s squared less than or equal to s squared cos x less than or equal to s squared. Then let's divide through by s squared plus 1. So I have minus s squared over s squared plus 1 less than or equal to s squared cos x over s squared plus 1 less than or equal to s squared over s squared plus 1. The middle, okay, the middle one is what I'm looking for. So let's find the limits as s approaches 0 of the left one, which is minus s squared over s squared plus 1. Is it approaching 0? Okay. How do we go about this? This is a rational function, right? Is it a rational function? Am I online?
Yes, you are online.
Hello, can you hear me?
Online.
So I'm saying that minus s squared over s squared plus 1 is a rational function. Do you agree?
Yes, please.
You don't agree? Okay, so what's the domain of this function?
S square plus 1.
The domain of this function. What is the domain?
All real numbers except 1.
Are you sure?
Just all real numbers, except that x belongs to the set of real numbers.
Okay. So the domain is the set of all real numbers. Okay, so 0 is also a real number. So we're told that if the x, a is in the domain, I'll just substitute my a. So let's substitute 0 into it and see what we get. What do I get when I substitute 0?
0.
I'm going to get 0. Then let's find the limit for the left one too, which is s squared over s squared plus 1. And what do I get for that one too?
0, please.
0. Okay, so from the squeeze theory, since the right hand side is 0 and the left hand side is 0, then I can conclude that the limits as s approaches 0 of s squared cos s over s squared plus 1 is 0. Okay, so that is it. Yeah. Gifted.
Yes, madam. Madam, please, why did we divide it by s squared plus 1?
Because the original function is s squared plus 1. The original function is divided by s squared plus 1.
Oh, okay.
So since the left-hand side is 0 and the right-hand side is also 0, then we can conclude that by the sandwich theory, the function in between will also be 0. Okay, thank you very much. I want to move on to continuity. But anything about what we've done so far, the limits. You can read more on limits. You can get more questions on limits. But anything before I continue with the continuity?
Madam, please continue for us.
Okay. So continue. So he said I should continue. So we want to we want to look at continuity, continuous. So you've seen that since I started, if not for my network, the lecture has been continuous. If today we did not have any break, so no break. So when we talk about continuity or continuous function, we are talking about a function whose graph has no break. It is continuous. So the common usage of continuous signifies behaviors without break. So today our lecture, internet. Then today our lecture has been continuous because today we've not gone for break. So this is an example of a continuous function. Our lecture has been continuous. So the term continuous is used in calculus to describe functions whose graph have this type of behavior. Okay, so the graph is like this. There's no break. So anything that you can picture without break is a continuous function. So I have something like this, then it's go like this and this. And so if I go down, it's like this. But if I want to just look at, so a function like this without break to infinity, it's a continuous function. Okay. So this is a continuous function. But when we look at this, here we have a hole, some hole here. So this is not continuous. Here we have something like this and something here. So this is not continuous. This I have something like this and something like this. So this is not continuous. So it says that as some examples of not continuous functions or discontinuous function, we can look at the first one. You move and then there's a small break. We call this kind of discontinuity a hole. And then we have something like this. This kind of discontinuity, we call it a jump. And then we have something like this. We call this kind of discontinuity vertical asymptotes. You can read on different types of discontinuity. Okay. So we can talk about whole, jump, and then asymptotes. So this one is when you are given the graph. When you are given the graph, you can say whether it is continuous or not. But what about if you are not given a graph and then you are given the function? So when you are given the function, that's how to find out if it is continuous or not. So first, you substitute your a into the function. So if your f of a exists, that is if a is in the domain. So first you have to find out if your f of a exists. Then two, you have to find the limit as s approaches a of f of a. So if the limit exists, you put it down. Then you compare your I and II. If your I is equal to II, then you conclude that the function is continuous. If a function fails any of the three rules, then it means that that function is not continuous. So it says that if a function is not continuous at A, then f is said to be discontinuous at A. So example, please excuse me. Oh, what please excuse me. Let me wait a little.
This rate is a whole. Now, I think
Exactly.
the class is asymptote. They are vertical.
Jump. I really let you know time reading the Bible. Yeah, some.
Okay, I think the whole class remember these things. This is yeah, Kasao. You are going for a vertical asymptote.
Master, some of the comments I'm very careful because she's still on the page. Be careful. I also Mananka.
The session is being recorded. Please, let's comport ourselves.
Hello, please, I'm here. I'm coming in. Hello, I'm here.
Madam, please, we are also here.
So I will join soon.
Okay.
Yo, Uncle was so. Go ahead, I'll call by to you. But I'm actually.
Nothing I'm waiting on the process and look up in class. You don't know about 8 not come up, but they are.
Hello, I'm sorry. I got some visitors from fire service. So please forgive me. Let's continue. Okay, so we want to determine whether this function f of x is equal to x squared minus 4 over x squared minus 3x plus 2 is continuous at 2. So for continuity, we are told that first we have to find f of a. So let's find f of a. So we are substituting s equal to 2. So s equal to 2, I have 2 squared minus 4, which is 0, divided by 2 squared, which is 4, minus 2 times 2, 3 times 2, which is 6 plus 2. So the top is 0. The second one, what do I get? The denominator, what do I get? Hey, am I online?
0.
It's 0.
Okay, so numerator
0.
is 0. The denominator is 0. So what do I get?
Undefined.
Undefined. Thank you. So from the first definition of continuity, we have f of 2, which is 0 over 0. Thus, f of 2 is undefined. And I said that if it fails even one of them, it means that it is not continuous. So since it has failed the first one, we don't have to continue with the others. So since it is undefined for the first instance, then
Madam,
it
please,
means
question.
the function is not continuous. Yeah, please ask.
Hello, madam, please, where did you get 2 from? That a is equal to 2 that you substitute into the equation.
It's in the question. Determine whether the function is continuous at s equal to 2. It's in the question. Are you okay?
Okay, thank you.
It's part of the question. Okay, so thank you very much.
Thank you.
So since it is undefined, yeah, good morning. My mom, yeah. I'm the one. Oh, okay. Okay, she's going to Takrady. Yeah, I remember. She's going to Takrady. She's now in Takrady. She's my mother. Yeah, she's going to Takrady for the Christmas. I'll tell her. Mr. Egan, I remember your name. That day, you remember I came to. Yeah. Okay, thank you very much. Merry Christmas to Mr. Egan. I'll tell him. Thank you. So sorry, Mr. Bonti on Team Patron Chena never consume Benjamin. Please let's continue. The second one. Okay, thank you. The second one, want to find the constant c. That will make this function, the function that's defined or continuous at s equal to 1. Okay, so the definition, the function is x squared minus 1 over x minus 1. You know that when s equals to 1, this function will be undefined. Do you agree?
Yes, madam.
Yes,
That when s equals to 1, I have 1 squared minus 1 over 1 minus 1, so it will be 0 over 0, will be undefined. But I want to look at the function c. where the function will be defined. Okay, at s equal to 1. And we know that the only how to get that function c is to simplify this function. So I want to look at the limit as s approaches 1 of s squared minus 1 over x minus 1. And to simplify, s squared minus 1 is the same as s plus 1, x minus 1, all divided by x minus 1. So x minus 1 will cancel. Then I have the limit as s approaches 1 of s plus 1. So s plus 1 will be equal to 2. And that constant I'm looking for is the value 2. It says that but for f of s to be continuous, we'll need f limits to be equal to f of 1. So now the new function is x plus 1. So when I find, okay, so what I'm talking about is this. So the function is s squared minus s over x minus 1. When I simplify this, I have s plus 1, x minus 1, all divided by x minus 1. This goes with this. Then I have s plus 1. So for continuity, I have to find f of 1. The value given is 1. So f of 1 will be 1 plus 1, which is 2. Then I have to find the limit as s approaches 1 of s plus 1. And this will also give me 2. And the last one says that, so this is I, this is II. The last one says that f of 1 should be equal to the limit as s approaches 1 of f of x. And we can see that both of them are 2. So since they are equal, then it means that the function this is continuous. And that constant we are looking for is 2. Please, are you okay?
Nah.
Okay, thank you very much. Then the last thing that we want to look at is the derivative of a function. We all know, so we know how to find out if a function is continuous or not. So whether it's a graph, if it's a graph, we know that the graph do not have any break. And if it's a function given, not a graph, you know that it should satisfy the 3 rules. Okay. Faster.
Okay, madam, please. If the graph is being drawn already, what are the things that you should inspect or expect
If the
for the
graph
graph
if the
being
graph is done
drawn
already,
already? Yes, please. What are the things we are supposed to how do you call it, expect or inspect in order to conclude that the graph is continuous or otherwise? Thank you.
so we saw that a continuous graph is a graph without break. So when you see any break, either a hole, a jump, or maybe asymptote, then it means that it is not continuous.
Thank
Are
you,
you
madam.
okay?
Yes,
Okay.
please.
Okay. Thank you. Let's continue. We all know how to find the slope of a straight line. We simply divide the change in y by the change in x. This is commonly known as rate of change. We know that, right? So change in y by change in x is the slope. Slope of linear equations are constant across the entire line. However, if we consider a curve, there wouldn't be a constant slope for the entire graph. In such instance, we seek to find an equation that we can use to give us the slope of a line tangent to the curve at any given value of x. Using this equation gives us the instantaneous rate of change or the slope at a specific point on the curve. So we want to look at the definition. So we know that if it's a straight line, the slope will be the same throughout the entire graph. But if it's not a straight line, but it's a curve, there may be changes. So the definition for the slope, which is the same as the derivative or the change. The derivative of a function is a function given as f prime, and it is defined by the limit as h approaches 0 of f of x plus h minus f of x divided by h. Okay, so f of x plus h is the small change. So this is the definition of derivative. So when you are asked to use the derivative definition, it is the limit as h approaches 0 of f of x plus h minus f of x divided by h. So example, we are to use the definition of derivative to find f prime of x. If f of x is equal to 4x plus 2. Okay. So this is what we do. So my f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. So I have to find my f of x plus h. So it means that wherever I see x, I add h to it. So this will be 4 into brackets s plus h minus 2. So that is for this part. Then minus the original f of x. So the original f of x is 4x minus 2. Then everything divided by h. When I open the brackets here, I have the limit as h approaches 0 of 4x plus 4h minus 2 minus 4x plus 2 all over h. My 2 can go with the 2. My 4x is positive. It can go with a negative 4x. So I'll be left with 4h over h. Then h can cancel h. Then I'll be left with 4. The limit of a constant is the constant. So this will give me 4. So using the definition of derivative, which is also known as the first principle of differentiation, the derivative of f of x is equal to 4x minus 2 is 4. There's another one here. We want to use the first principle, which is the same as the definition of derivative, to find f prime if f of x is equal to 1 over x squared. So here I have to find my f of x plus 1. Plus h. So my f of x plus h will be 1 over x plus h all squared. So that's what I have here. 1 over x plus h all squared minus my f of x, which is 1 over x, all divided by h. So I find LCM for this, which is x squared into x plus h. Then times my h. Okay, so the h, we can put it somewhere. Then I'll focus on x squared into x plus h all squared. When you simplify, you're going to get x squared. So this will go into this x squared times, and this will go into this one, x plus h all squared. When you simplify, you're going to get x squared minus 2xh minus h squared. X squared can go with x squared, and I'll have minus h into 2x plus h all divided by x squared into x squared plus h squared h. Then this h can go with this h, and I have minus 2x minus h divided by, still looking at the limits, x squared into x plus h all squared. Okay. Now my h is equal to 0. So when I have 0 here, I'm going to get minus 2x over, then I have x squared. So minus 2x over x to the power 4. And then this s can go into this one. Then I have minus 2 over x to the power 3. Okay. So when you use the first principle to find the limit, to find the derivative of 1 over x squared, you are supposed to get minus 2 over s to the power 3. Please, you can take your time. The most important thing that you need here is be able to write it like this. But the simplification is to be able to do it. Okay. So you're going to get minus 2 over s to the power 3. Okay. So these are examples. You can go through them. You want to find the limit for the following. So these are examples. You want to find the constants. Okay, so determine whether this function is continuous, whether the limit exists. Then other ones, we have some examples here. Okay. So please try and solve them yourselves. So I am done with the first principle. I'm done with continuity. I'm done with limits of a function. Any question? Please, any question?
No, please.
Okay. Then if you are okay, then maybe we'll end here. Since today is 31st, some of you want to do other things, and then maybe you sleep and prepare for 31st night. Okay.
Madam, please, can we get a slides?
Yeah, I'll share it with you.
Okay.
Okay,
And
so thank
the course
Mhm.
outline, please.
Course outline. I'll look for the course outline, but I'll share the slides with you. The course outline should be somewhere. Please, I'll share it with you.
Okay.
Madam, please, so in case you are having the other unit slides, we'll be grateful if you will be able to share with us.
Yeah, I'll share everything with you. Okay, thank you very much, and God be with
I mean, sure, where
You are welcome.
I see you.
Madam, my regards to your mother.
Yo, thank you.
And Happy New Year in advance.
Happy New Year. See you all in 2026.
Amen.
Amen. Oh, amen. Amen.
Okay, thank you very much, and
You're
enjoy the
welcome.
rest of the day. Bye-bye.
Bye.
This one was just reading the try.
Yeah, you must read it by yourself.
Please don't complain. Let's just take it like that.
Recording is on. Recording is
Nobody
on.
complain.
I
Say
say,
yes.
just reading the try.
Adie, you better say share peer to peer now because you may be an anti share you.
She was just reading, senior. She was just reading the slides.
Please, I want to find out would they do it at peer to peer? Please, someone should help me.
Hey, are you sure the recording is
No,
not
please. No, they won't do it again.
Hey, they will not do it again. Hey, you will be a woo.
Yes, please.
Because in fact, I didn't understand anything though.
W.
Please let's comment in our various WhatsApp platforms.
The recording is on. Let's yes. So.
Please, we can get to our various platform to comment. Here, let's just
that one will help. Yeah.
This place, madam is on, so please, let's just go to our platform and do the commenting. Otherwise, you just get to the peer-to-peer lessons. We'll meet them. Don't worry. They will do that.
What you are saying is true. You're also together. So just reading kake. Haba. Mbada mfuka.
Who's a horn? You can't say what you told you. I know I'll boom it. I'm saying, I may be. Saturday, I'm going to put tonight. Table, I'm going to be this. I'm body never. It's a table. I'm going to be open me now as ten. And no family. Or let me pay for money. Then all you assembly see almost friend. We need to do it. Okay, oh, mayor and I. Mayor and I. Almost about 2 years, 7 next year, and I'm and why I would miss out to me what I need to and charity. Somebody to the make he's so what to wish friend. Someone else to the enemy. Yeah, but yes, yeah, but has him.
No, but you don't so long.
Madam Banning, Cinnamon, man.